What we are talking about today, we are talking about a little bit about SolarWinds Executive Order of Cybersecurity, ASBOMs, and so on. And this talk is available in German as well as in English. So today we are hearing it in English. And so what are we doing? So what happened in the past is one thing. So I will highlight a little bit what happened and why this was so important to us and why this was leading to all this stuff that's going on now. And it's nothing easy because I think the wave that's coming from the US with all these regulations and requirements is a little bit bigger one. So we should be prepared. And I want to highlight a little bit the reaction of the US government as well. So how this works, why this is important even for us if we are in Europe or somewhere in the world and we are not so tightly bound to the US government, but why it will affect us and how we can prepare and what tools are for free available for you so that you can just start immediately. So what we want to learn. So we want to learn a little bit how we can prepare against attacks against supply chains. And if you are just at the beginning of working with cybersecurity stuff or security in general in your software development, how we can start and what you can do. So any questions so far? So let me check. The chat is here, nothing here. The Q&A, nothing here. Let's not. Oh, no, this way. By the way, my name is Sven. I'm from Germany. And since COVID, I'm not traveling anymore, but I'm running to the forest. I just love it. So if you can see here, that's just a screenshot of my regular recorded YouTube videos, because instead of traveling to conferences, I'm doing this virtual one and I'm recording my talks and presentations as well in the woods. So if you want to see Java related stuff, security related stuff, and this in the forest, then have a look at my YouTube channel. I really would appreciate to see you as my new subscriber there. I have it in German, I have it in English. This is my German one. Then you can see, okay, there are a lot of talks and it's a tiny YouTube channel. So I'm not one of these famous YouTube star with millions of subscribers. So I'm just a tiny YouTube channel and I really would love to have more subscribers. This, by the way, is my English channel, so feel free. And if you have really no interest in Java or cybersecurity and just want to see something else, go to my Bash drafting channel. This is a private one. Definitely no IT stuff there, just how I'm spending time in the woods. Okay, so let's see. What happened? And this is more or less a beginning of how all this stuff changed during the last year or 1.5 years dramatically, the IT landscape in some environments. And I'm focusing here on the security part for sure. So what we could see is that there is no dedicated attack against a final target. So this is still happening for sure. But the main thing is that with all this stuff, we have now attacks against supply chains. So it means they are not addressing the final target like this institution or this governmental thing or this company. So they are going to multipliers. They're going to multipliers in a way that they want to influence or change a few things that are distributed by others. So what happened here was the SolarWinds Hack, just as a short recap. So SolarWinds is this company that's building a very critical piece of software, and this is this Orion platform. And this Orion platform is a tool to manage network infrastructure. And the network infrastructure inside the company is a very critical infrastructure because you have directly or indirectly access to everything. And so many projects or company networks, I see that even inside the company network, the critical connections are not encrypted because they're inside the company network. Still this I'm seeing, but this is more or less really the pain what happened with SolarWinds. So what happened is they broke into this company network from SolarWinds. Then they are not compromising some stuff or stealing data or doing a denial of service attack. They changed the CI pipeline. So, and inside the CI pipeline, what happened is that with every build of a new binary, they put some compromised piece of code in. So they created this binary, then they added their compromised stuff. And at this point, the company SolarWinds have in mind that they have over 300,000 customers and they have this automatic update mechanism. They provided a compromised binary itself and all so old-fashioned techniques like I'm going to the provider, I'm checking the fingerprint and then downloading the software, checking again the fingerprint. So if this binary is not compromised, it's not working because the company itself was producing compromised binaries. So this was pushed out. And they affected, I think, immediately 15,000, 16,000 different networks. We are not talking about servers, we are talking about networks. And in these networks, they are huge networks because it was space, military, automotive, insurance, health, whatever. So all these big companies, because they have the need to have some tool to manage network infrastructure because they have huge networks. So this was really pain. So this binary was there. 1 or 2 weeks sleeping and then started downloading additional binaries and additional bytecode. So every infection with SolarWinds is slightly different. So if you're closing one, or if you're shutting down the core SolarWinds executable, you have a lot of different open windows, and it was really pain in the ass. So you don't have any idea what binaries are somewhere in this network doing some stuff. And mostly it was just leading to destroying the whole network and rebuilding from scratch. But for us as software developers, what's the lesson learned? The basic lesson learned here is that at this point, we have two sides of this attack. The first thing is what we are all afraid of. We are grabbing compromised stuff. Okay, we are grabbing some binaries from somewhere and this is compromised. On the other side, what's sometimes even worse is not only consuming compromised binaries, is to the distribution of compromised binaries. So if you, as a company, distributing compromised binaries, you're losing all the connections or the trust from your customers, and this could be even worse. So so we have now these two sides. We have this how to consume, or we are consuming compromise and we are pushing compromised binaries, and this will lead to a two-dimensional thing that we should be aware of in all directions and everywhere, because we are talking not about the production system, we are talking about our production system from software developers, about the CI environment, about the tooling, about all this stuff that's involved. Okay, so there was a reaction, and this is the executive order. So this SolarWinds hack really pushed a lot of compromised binaries everywhere. A lot of networks were down. A lot of very sensitive infrastructure was infected. And the US government was really afraid of. And they started with an executive order. So I'm not a US citizen, so I had no clue what an executive order is. So I really had to go to read on Wikipedia. I asked some US citizens to give me an understanding what's an executive order. The executive order can be given by the US president. The US president is able to give some directions in a way the governmental institutions are working. So let's compare it with the CEO of a company. So a CEO can't change the law or the tax law or whatever. It's the same with the US president. He can't just change law and saying, okay, now this is new law and something will happen. But in the same way an CEO can do it, he can change the way the US government is working. So back to the example with the CEO. So the CEO itself know what are the rules, what is the law, and internally in the company, he can restructure or reorganize the processes immediately. So now we're doing it like this or that, or this must be done first and second and so on. And the US president can do the same. And this is called the executive order. So he can do a lot of them. And the executive order of cybersecurity, we will come back to this topic a little bit later, is in a way that they changed the way how the IT of the US government that is used actively or indirectly, the usage is changed. So he defined the requirements, what he requested. We will go a little bit further and see what are the 4 main topics of cybersecurity or cyber defense, so that we are understanding why they focus on exactly this part of cybersecurity. But having in mind an executive order is changing immediately the way the government's working, and this having in mind that the US government is spending millions of dollars for creating software, using software, means that all directly or indirectly involved parties are now tightly bound to this executive order. So I'm in Europe, I'm in Germany, and I'm not working for the US government, but it will hit me because if I'm creating something or working on a product that is used by a company that is working directly or indirectly for the US government, they have to fulfill this requirements. And this is why it's so important to understand, okay, there is something that's just affecting immediately the US government, how they are operating, but even here, for me, it will change a lot of things. Talking about the 4 basic parts of cybersecurity, cyber defense, or security in the DevSecOps environment, or whatever you want to say to it, you have this 4 main parts. The 2 main parts, the traditional main parts, are, for example, inside the dev environment, the SaaS, the static application security testing. What does it mean? Static application security testing means that you're grabbing all bits and pieces inside your environment and you can start scanning it. And the word static means you have no access to the dynamic context of this application. So you have access to 100% of all components and you can analyze them. It could be source code, binary, configuration, whatever, but in a static context. So we have there 2 main things inside the SaaS part, the static application security testing. It could be the dependencies, everything you're grabbing as an external dependency, checking this one, and you can scan your source code, for example. To tell the truth, scanning your own source code is critical, or not, it's not critical, but it's not so effective these days, because the tools we have to look at this source code, they're doing it with AI, machine learning, whatever, they are not able to cover 100% of the behavior of this piece of code, because we are talking about the static context of an application. So this tool will increase, this will be better and better by time. But right now, it's good to have, but it's not so easy to understand and it's not so secure as you see. And we should focus on binaries. I will explain it a little bit later why and what is the mechanic here. But the basic part, purely from the dev part, because nothing's running so far, is the SaaS part. The complete opposite of this is the dynamic application security testing. The dynamic application security testing is doing it like a hacker. So you have something that is running, and then you try to attack this system. Mostly these DAS tools are based on the mechanics of the most common vulnerabilities. The most common vulnerabilities are something like SQL injection, buffer overflow, and whatever. So there's a list of the most common vulnerabilities, and just check in Google, so most common vulnerabilities and OSWAP and all this stuff. So you will find a list, and this will slightly change, but it's more or less the application must run with a configuration in some hardware environment, and then they try to break into the system. So, and with this automatically generated attacks, you have a few pros and cons. The pro is definitely if you're running an application and this is running on production, not some staging, not some testing environment. I mean, really, with the right configuration and the later used hardware, this software, if this is running, then you have exactly this dynamic context, this running in production thing, and then you try to hack, and then you can see if there is, for example, a bad configuration, if there is some open ports and all this stuff. So you have access to the dynamic part. The good thing is you don't need to understand the mechanics inside the application. You don't need the knowledge about the use technology and libraries and all this stuff, because you have just this interface. And with this, we are talking indirectly, mostly about web applications. We are not talking about desktop applications. So because you need some way to access it. You can do DAST, Dynamic Application Security Testing, with desktop apps, for sure. But mostly, we're dealing with web interfaces, REST interface, whatever. So with something that is running and accessible over network. So this Dust applications, the cons is that this attack is time consuming. So you have a huge amount of combinations you can do. And with every new open port or service, you have a huge additional range you could test. So we are talking about multi-dimensional, that's a critical word for me, possibility of attack vectors. And to run all these attacks is time consuming. If you have a bigger web API, this will increase over the time. And mostly these DAST tools are software as a service tool. So you have, or the need that you have over an VPN or directly over the internet access to this service provider that will attack your system. And definitely a weak point is that if you're using Dust early in the development stage, so you're testing in a test environment, you have to be sure what does it mean if you have weak configurations, or if you're testing against different hardware or scalability options and so on. So it's not so trivial, but it's time consuming. And the worst part here is you need something that is running already. So you're quite late in its production stages. So these are the two opposite things. So mostly Dust is focusing on the ops part, and Dust is focusing on the dev parts. If you have a DevOps environment, what would be the first thing we are learning? For sure, we're just merging it. And this is what I'm highlighting here a little bit gray. It's IS, this interactive application security testing. So it was a logical point to shift this dynamic application, so to get the information about the dynamic context a little bit more inside the production stage, so earlier shifting left. And then you're merging it with your dev part. So IS will scan the binaries, for sure, all these bits and pieces internally. Then they try to let it run and have the Dust part running. And the interactive part means that you need someone that's able to design attack vectors against your application. So this is the interactive part. So you have access to the source code and all binaries, you have access to the dynamic context, and now you're interactively pushing an attack vector against your system. And mostly, to tell the truth, you need someone that is very, very high skilled with this, because this is nothing what you're learning just in a few weeks. So you really need to understand the involved technologies, how to create attack vectors, what is the state of the art of this. And at the same time, there's having in mind that these Dust tools, jumping back to the pure dynamic application security testing, if they're focusing mostly on the most common vulnerability attack vectors, or based on this one, then if there's a new attack, the Dust tools mostly need some time to adjust to this new kind of attack vector. And mostly if it is a software as a service approach, it's not so easy or even not possible to define your own attack vectors. They try to mix it a little bit with fuzzy logic and all this stuff, for sure. So they're involving, but defining your own attack vectors is not so easy. So this is a merge of Dust and Dust to IS, interactive application security testing. And the next thing is this Rasp, this runtime application security protection. So here we are not testing. So Rasp is the last one I want to mention here, because this is purely focusing on production systems. So the system is running already really in production. And then it's in a way that this piece of software try to identify if there is an actual attack going on. So Rasp is the tool to identify there is an attack and try. So you have two choices. So just this monitoring mode. So it will identify an attack and will give you a message, and then you have to decide, or this self-healing approach that this software will try to identify, okay, here are requests that are, they're looking dangerous and they're just shutting down this piece of your system. So this is Rasp. The good thing with Rasp is that you're identifying active ongoing attacks, for sure. The bad thing here is, first of all, you use mostly this agent approach. That means you have this tool that's tweaking the bytecode of your application. This is a little bit performance overhead. But on the other side, the critical thing is that in some environment, this agent approach is not allowed because you are modifying the protection system and having in mind even this agent could be compromised. Yeah. So, but on the other side, this identifying there is an active attack is quite good. On the other side, the dev parts or the developers mostly tend to say, okay, it's not so important that I'm fixing all security holes because there is something that is scanning production and it will fix it later. So that's more or less a mental challenge. But these are the four pillars or the four stages or the four groups of cybersecurity. So scanning the static application, scanning the dynamic application, merging this both approaches somewhere in your DevOps environment and doing this interactive attack so that you are defining very special attack vectors against yourself, or checking the application that's running in production and try to identify this hacks. So what is SolarWinds? SolarWinds they were able to identify with Rasp that something strange is going on, but this was too late because it was after the infection and then it was already inside. Then this SolarWinds, could it be checked with an interactive application security testing approach? Well, not really, because it's the statistics or the possibility that you have the same idea to attack the system in this way is it's tiny. So dynamic application security testing, would this work against the SolarWinds attack? Maybe. The static application security testing, this would be something that could help. So, and because you're dealing with all these bits and pieces, you're building something together. And this is more or less what the cybersecurity executive order of cybersecurity was going through. Okay, having a look at this mechanics of this static approach. So the early thing you could do is you can do all the security scans inside the static application, because this you can do immediately. If you start with first line of code, you can start scanning your system. But you have two dimensions. You have this dimension of this more generic approach, this technology independent approach, and this purely technology approach. For this, I will just use this term cloud native. It's just an excuse. It works in the same way with monoliths, with serverless, with whatever you are talking about. But you have, for example, in this environment, this service-oriented architecture. It means, is there a way that a tool can help you to divide all your use cases in a secure collection of microservices? No. So you as a human has to decide, okay, this use case is a microservice and this one is the next one, or there's a service and how they are connected and all this. So is there a tool that can help you to identify the information that's going from A to B is in a secure way, or could be compromised on a business way or whatever? No, not really. So this is a very generic approach, and mostly this must be done by humans because our tool set is not so strong. Talking about the API-oriented communication or some kind of communication. So what the tools are? The tools can help to make this communication itself encrypted, for example, or safe. Yes, for sure. But to decide if it is secure to send over the wire exactly the pieces A, B, and C, That is something generic. So again, this must be done by humans, but here we have a little bit more technical approach with how to make a secure end-to-end communication. So the tools are stronger here. Talking about container infrastructure or this resilience and this ramping up and down of microservices and all this stuff, now the tools are better because it is a pure technical thing. There's no domain-specific thing. There's no this generic approach. So it's a pure technical thing. And here the tools are stronger and stronger. But if you're talking about the DevSecOps environment, so your own environment where you're creating stuff, here the tools are really, really, really good because this is a pure technical thing. So scanning binaries, analyzing source code, ramping up, ramping down stuff. The CI environment, is it secure, yes or no? And this is a question to you. Did you ever scan your CI environment? I mean, the SolarWinds hack attacked, I don't know what CI environments they use, but they attacked the CI environment and compromised it. So did you ever check your Jenkins, for example, against vulnerabilities if someone can compromise it in a bad way? So, and if you're talking about this evolution of software now, we have the shorter release cycles, it's good, but on the other side, we have more time that something can break in. It's okay. The shorter lifetimes of this microservice, it's good if you want to get rid of technical debt in terms of old technology and whatever. On the other side, you have most likely this approach of, oh, I'm throwing it away, I'm rewriting it. It's easy. But with a rewrite, you have a different beast of making it secure again. And it's even worse if you're talking about polyglot environments. Say, okay, every microservice now written in a different technology, and I'm working in Java since ages, but if I would write now in Go or something, I would learn maybe faster than a person that just started coding, but the compiler, the behavior, the libraries and the ecosystem and the community would be completely new for me as well. So I would do a lot of mistakes again that I wouldn't do with Java. So polyglot environments are definitely a challenge. Okay, throwing all this stuff away, just focusing on one single point. You have these different layers, this application, operating system, virtualizing, then this orchestration of virtual nodes and all this stuff. So what we can see is that we have, with every layer, new technologies, new possibilities to break into, to have new vulnerabilities. And the most people, they're talking about security in terms of vulnerabilities. But for me personally, compliance is an issue as well. So it's really worse if you have the right license at the wrong point inside your production line. So because this could be destroying a business as well. So, but focusing on vulnerabilities, you have these vulnerabilities in every layer. And with every layer, we're getting more vulnerabilities. So from the mathematical point of view, we adjust with every technology layer, with every abstraction layer, we're increasing the amount of vulnerabilities. And we are talking about known vulnerabilities and unknown vulnerabilities, but just general, this approach, this vulnerabilities per layer. If you're adding a layer, we're adding vulnerabilities. So in the whole system, we have a bunch of layers adding more and more vulnerabilities, but from outside, we have now the full amount of vulnerabilities in the whole infrastructure. And here we have two things again, with this technical approach inside this service and the domain specific. I'm not talking about the domain specific approach of making this business case secure against that it could be compromised in terms of wrong text calculation or whatever. But on the technical side, we can work very hard against it. So if there is a possibility to have a secret injection, yes or no? The most people, again, forgetting the whole dev stack, compilers, IDEs, C environments, shell scripts, whatever. So the whole tool stack, okay? Because this could be compromised as well. There's this term shift left. I was able to remember this one. I'm just rotating this picture and saying, okay, shift left means as early as possible fighting against vulnerabilities or security issues in general. And this means starting straight in the application because per definition, we're adding and adding and adding more and more vulnerabilities and security risks. That's it. If you're now looking at all these tech layers you're adding, there's one thing in common. And this is an application, for example, if you're writing it in Java, then you have maybe Maven dependencies because you're declaring dependencies with Maven, with some dependency management tool. If you're going to the operating system, we have maybe Linux, and then we have Debian repositories as well. So Maven repositories, Debian repositories, Docker repositories, Helm charts, and so on. So we have for every layer mostly some kind of dependency manager that is connected through this. And then again, most people forgetting that the whole tool stack could be something like a generic repository as well, because we are dealing here with binaries, with stuff we are using, tools. And all together is something like, if you want to have the whole picture of all possible attack vectors and known vulnerabilities, then you need something that is focusing or reading all binaries, and at the same time is able to understanding the metadata. And this metadata, this is important to know because it's not only the binary itself, it is a whole understanding of what is going on here. So, well, next step would be, a lot of people are talking about time to market, make or buy. So what I'm focusing here is, if you're talking about security, it is in a way that if you have a use case, the whole company is clear to say, oh, there's this use case, we have this description and do it and push it to production because we want to write a bill. We want to get money for it. So it's fine, we're doing it. But if you're talking about security, then immediately people start changing the processes. So it's just a requirement. So requirement is clearly defined, removes the vulnerability. So it's the same like implement this use case. This requirement is done, but why these processes to do all this stuff are different. So I never understood why companies have for use cases a fast lane, a very fast track to deliver stuff. But if you're talking about vulnerabilities, they have a complex process. So with commitment here and checking there and some people involved and all this stuff, and this makes it just slow. So if you want to prepare against this security risk, make sure that your processes are tiny, fast, and not different to any other requirements. The same with make or buy. So most people know, okay, if we don't have this knowledge, maybe we are looking at the market for an external one that is jumping in and he will do some stuff for us. What we will have, we have the need to trust this external people that they're doing it right. We have to check their results if this is working well. We have to deal with, so this ecosystem is not just there's an external, he's doing something, he's leaving, but we as software developer, we are doing exactly the same. We are just, oh, there's a dependency. It is make or buy. So we are not doing it by ourselves. We are not creating our own PDF library. We're just adding a dependency. And this is like an external. It is in a way that we're indirectly trusting other people, and we are just grabbing this dependency. So yes, for sure, it's good. Don't reinvent the wheel. So use existing stuff. But on the other side, it makes sense to check what's coming on. So what we are doing with this stuff, where it's coming from, who's doing it, and so on. So have in mind that every dependency we are using is something like trusting. Talking about dependencies itself, so why they focus on the static part, and going back a little bit later to this executive order, is if you're looking at this whole tech stack for every layer, then what we see is that in every layer we have some kind of, we are doing something and we are buying something. Inside the application, source code is we're doing something, and the dependency, adding a dependency, is buying something. So the values, or the different values of how much I've done and how much I'm adding as a dependency, most likely is in the project that the lines of code we're adding is by far bigger than what we are writing by ourselves. And that's even worse in all other layers. So Linux, for example, I'm just writing a few configurations, and the rest of the operating system is a dependency. It's just grabbed. And with Docker the same. So I'm writing a Docker file, even if I'm still writing a Docker file, sometimes not even this one. And the first line is a from statement. So I'm starting with a dependency already. Yeah? And the same with Kubernetes and so on. And again, the whole tool stack, we're not writing our own IDE, we're using an IDE. So comparing this value between what I'm doing by myself and what is coming from outside, the most environments and the most projects, what I see is that the amount what we're doing is tiny compared to what we are using. Okay, so, and this again, for compliance as well as vulnerabilities. So compliance is the thing with this license. So what license is used indirectly, directly or indirectly. And the initial effort here is just that someone has to define, okay, this is a good license at this production stage, and we can use this and that and so on. So someone who's able to do it or must do it or whatever, I don't care about this one, but someone has to define it. And then you can feed the machine and the machine can scan it. Makes sense to scan regularly against compliance issues? Oh, yes. Because if you have a dependency, all this transitive dependencies, they have license as well. And if someone of an open source project decided to migrate from Apache to Eclipse or whatever, so just highlighting here Jakarta EE, Eclipse EE, whatever EE, then we have changes inside your whole tree of compliance issues. Same with vulnerabilities. We have to scan constantly against vulnerabilities for sure, because we are still adding vulnerabilities or getting new vulnerabilities, but there is no initial thing must be done. So the machine can just start scanning for known or against known vulnerabilities. But we will find way more often changes against vulnerabilities. So we will find more vulnerabilities. So we have to do on a regular basis something against it. So what is the big difference between fighting against compliance or vulnerability issues? Compliance issues are single dots in your whole tech stack. And the beast here is that if there's a compliance issue, you have to remove exactly this part. And then you have to find a semantic equal implementation. This could be a challenge, or you have to change a lot of stuff. With vulnerabilities, it's a little bit different. So vulnerabilities, to get rid of them, mostly it's enough to have another version of the same dependency. But not the good part with vulnerabilities is that you can combine vulnerabilities to different attack vectors. So it's not even not enough to just remove one vulnerability or just scan one layer. So you need to understand the whole amount of attack vectors against your full tech stack. So everything together is leading to some ideas about, okay, what is the early stage I am as a software developer can work against vulnerabilities? And for this, I just want to highlight the lifeline of a vulnerability in a way that I want to see what are the stages where I can influence something, or I can change something. And this was exactly the same idea what was behind this executive order of cybersecurity. So let's assume there is a vulnerability created. It could be accidentally, it could be purpose, whatever. Can I influence it? Not really. So I can do it in my own source code. For sure, I can try to work with best practices so that I'm not creating code that is really easy to break or compromise. But on the other side, from all those dependencies, can I influence it? No, I have no chance. And this is by far the biggest part. So then there is this vulnerability from a good one or a bad one, I don't care. Then there is this point that this vulnerability will be found. So can I influence this part? Well, I can have something like a bounty program. So, okay, try to find something or whatever. But if you're not a security researcher, you have not really the chance to identify there are new vulnerabilities. So it's a slightly small amount of people or developers that are able to identify vulnerabilities. And then we have two parts, the good one, the bad one. So if it is the bad one, what he will do his own things with this knowledge. He will sell it in the darknet or whatever. I don't know. Can I have some influence here? So no, nothing. I can't do anything. They will do something with this. If it is a good one, what he will do is he will try to find a place where he can push this information. So he will not hide this information, he will push it. The not so good approach, in my opinion, is going to the vendor and just let them fix it, because quite often I see there's a bug fix against security issues and no detailed information. It's just a regular update, no CVSS value, nothing. So if this is good, I'm not sure about this one. On the other side, you can create the CVSS value. By the way, if you want to know more about CVSS values, on my YouTube channel, I have the basics explained what CVSS is, its common vulnerability scoring system, what are the metrics and so on. And then they will define the CVSS value, is something between 0 and 10. So if it is really critical, yes or no, and why, and all this stuff. And then with this information, some people will just give this information for free, but the amount of people is tiny. Because this information is a huge amount of money. And a huge amount of money means that you're having this information and then you're going from one vendor DB, from one vulnerability DB company to the next one and saying, okay, how much money will give me for this one? So can I influence the way how this is done? No. What is the best vulnerability database I should select? Well, whatever I'm selecting, I will have just a subset because sometimes you will sell it here, sometimes there. So what I need is a superset of vulnerability databases. So I need an aggregation of different resources to build a superset to be sure that I have the most of the known vulnerability knowledge. So can I influence this one? Slightly, yes. If you like it or not, if you want to have the biggest superset and you want to have this information fast, you have to spend some money. If this is good or bad, I don't want to discard this one, but in reality, it's a big market. And if you want to have this information fast, you have to spend money. And with this, whatever resource you're grabbing, so if you have a commercial one, free one, whatever, there is this point that this information is publicly available. It's inside these databases and you have the access to it. So you have it in a way that the machine can work with this. You don't need something on text written down. There's a vulnerability and the CVE is whatever. You need it in a way that the machine can consume this. And this is the first time you really can start working against vulnerabilities. And this is the biggest and the most critical part. So the information is consumable by you. You have this information, for example, from X-ray. Okay, there's a vulnerability and there's dependency, and now you can start working against it. So if you want to prepare you as best as possible, you need to optimize your whole CI environment so that you can consume the knowledge about this vulnerability as fast as possible. And that means good CI environment, a good vulnerability database provider integrated as early as possible in your production line. But what is the best safety belt you as a developer can have? Well, this is test coverage. So TDD is a really good thing. So quality and security are going hand in hand, and you need a good test coverage. Why? If you have a compliance issue, you need a semantic one thing out, one thing in. If you have a super strong test coverage, then you can run all your tests against it. If it is green, you can just go and say, okay, done, perfect. If you have a new composition of the same dependencies in different versions, talking about vulnerabilities, you can just make a new composition of this version, let your test coverage run, and if it is green, just deploy it. So you can get rid or you can change the composition of versions of the same dependencies in a way that you are increasing or decreasing versions so that the whole amount of attack vectors and vulnerabilities is minimized against the version that you had before. So, and yeah, test coverage is really one of the stronger things you need because dependency management has a highest impact. Okay, why? The code I'm writing by myself is tiny compared to all dependencies. If I'm talking about all dependencies of the whole tech stack, I have the biggest impact. I'm talking about the static application security testing because I can scan all components. So I need something to have a place where all the binaries are from the whole tech stack with a knowledge of the metadata, with the whole information about vulnerabilities that are existing, and then with a strong test coverage, you can do it. I don't trust line coverage. I'm personally a big fan of this mutation testing. If you want to know more about this one, let me know in your JAG or whatever that I can explain it. We can have a workshop or check on my YouTube channel. I explained this one. And well, this is what you should do. Back to this executive order. So with this in mind, what are the biggest points to fight against this attack like this SolarWinds thing? So we heard that the executive order is able to change the way how the US government is working. And the content of the executive order of cybersecurity is that for every piece of software that is running, used directly or indirectly, they want to have this SBOM, this software bills of material. This means they want to have the full possibility to know all directly or indirectly software components that are used by this piece of software used by the US government. Okay, a long sentence. What does it mean? We have this application, we have all these dependency managers, we have this self-written code, okay, and then we have this huge amount of dependencies. And what I mean is a software bill of material would be a full list of all direct or indirect used dependencies. So all tiny bits of your operating system, all tiny bits of your Docker environment, as well as your tooling and your application. So all Maven dependencies, for example, and all transitive dependencies. So talking about this SBOM, there is a solution there since years, but now everybody is got this wake-up call, because how to create this software bills of material. There's this construction, this build metadata or build info. This is a superset of SBOM. So if you need to create an SBOM because you are delivering directly or indirectly something that is used directly or indirectly by the US government, then you need the way to build the whole ingredients list of your full tech stack. And the build info itself is something that will give you not only this information, it will give you a little bit more. So what is the basic idea of a build info? A build info or metadata of build information means that you have all the knowledge about the context during the time this binary was created. It means dependencies, environment variables, date, time, operating system, library versions, fingerprints, all binaries in a way that you can access them and so on. So this is the build info. So as much as possible information about what was part of this process to create exactly this binary. Perfect. So what is part of this build info? Well, as I mentioned, it is data in terms of variables, binaries, configurations, everything, as much as possible. There is no clear description of this is enough, this is not enough. So what's enough for build info? Well, enough is, it is enough if you are able to have a post-mortem analysis if something happens. What does it? We will see. But in good advice is grab everything what you can collect automatically. So you have requirements for this build info so that you can work very efficiently. It's immutability. So if this data is created once, it must be stored in a way that you're not changing it. Otherwise, you're not trusting it or it could be compromised. So you need some kind of repository or place where you can just put it. So it's not a good advice to have something like an XML or JSON file on your hard disk and then try to work with this. The next thing, accessibility. So if this binary was created on this agent, there must be a central place where it is stored so that all others in your production line can work with this one. And it's very important that not only a machine can read it, a human must be able to read it as well. So these are the basic requirements for build info. If you want to create a build info, then it's easier as expected in the beginning, because what you need is during the build process, you need something that's wrapping around this build process and extracting automatically all this information that's available from environment variables about the fingerprint of the included dependencies. So we have this tool that's free to use, and I think it's open source already. It's a JFrog CLI. It's a wrapper about this dependency manager that you're using during your build process, for example, for Maven. Then, if you have one central place where all this meta information and the binaries are, for example, this Artifactory and connected with X-rays vulnerability scanner, then you can connect with the JFrog CLI to this dedicated part, so to Artifactory, and then you have all the knowledge and access to the binaries you need for your build. Then you're building your project, and during this build, the JFrog CLI will create a file called build-info.json. And this file is more or less a superset of an SBOM. So you will find all the dependencies that are used, plus fingerprints, hash sums, and all this stuff, and additional information Maven version, Java version, date, time, operating system, whatever. So a huge amount. So if it is on a CI environment, or if you have done it on command line, doesn't matter. You have all this information. So this build info.json, what's the place to store it? You have it in your target folder. Nice, but to work efficiently, it must be pushed to a place where everybody have access. It's immutable, and you can combine it with different data. And this is an artifactory called the build info repository. It's a dedicated part inside the free tier. So just go to draftrock.com, grab a free tier, and then you have artifactory, an X-ray, and inside you will find this build info point. And then you're deploying this build info to this artifactory instance, and then you have the possibility to read this file in a human readable, so in a nice graphical user interface, but additionally to the whole dependency list. For example, you have an actual list of known vulnerabilities. You have the possibility to create a diff between two build informations and so on. So you can start working with this. I don't want to go too much in detail here about this one, but if you want to try it out, you have different possibilities. First of all, you can register for a free workshop. Okay, then we're doing it together. Or you're just going to my YouTube channel. I have there how-to about build info. Then you can just see how I'm doing all this stuff on command line. Or what else? Yeah, just contact me, ask me. So, and with this, I'm more or less in the end. So what do we have, or what have we done? We learned that the basic thing of these attacks against the supply chain is in a way that they try to modify your production system. It means you need to know everything about it. And if you have a central place where all these binaries are coming, then you have the biggest amount of information you can use, the static application security testing. So if you start with security, start with SAS, static application security testing, because you can scan all your components. If this is done, then you can use something like DAST, dynamic application security testing, to work against the dynamic context of this application, but this is done later in production. And if you're really advanced after this, you can do something like ICE or Rasp. But mostly, if you want to start, focus first on dependency, because the biggest impact is low-hanging fruits. And if you have to create something like an ASBOM, all this stuff, and you're working with SAS tools, then you're mostly done with this requirements. So yes, I think we are done with the time. So I think we are slowly here. Any questions here? Let me know. So let me check the Q&A part. No questions so far, and nothing in the chat. Okay. So inside the chat, I will give you the easiest way to contact me. So if you want, okay. So you have, first of all, my blog. You will find a bunch of articles about this one. If you want to connect to me, go to LinkedIn or connect via Twitter. And if you want to read more or hear more about all this stuff, then I really would appreciate to have you as my new subscriber on YouTube. Okay. So any other questions?
So thank you so much.
Yeah, welcome.
Yeah, it's a pity that people are not asking questions.
It's normal. So if you have any questions, feel free to come later to me on LinkedIn, on Twitter, or whatever. And or just come to my workshop. It's for free. So then we can try, and then we can do it together. Or if you're in a Java user group, let me know. Then we can have a community workshop there and can do all this stuff. So there are so many ways to contact me. And